Well, good morning, everybody, and welcome back to the CIB Presidential Seminar Series that we are broadcasting here from Purdue University. It goes all around the world. As you will see, we'll have many participants signing in from around the world through the web. And as you know, the theme for this semester is Distinguished Women Researchers in the Built Environment. And it is my distinct pleasure to invite our speaker for today, Dr. Aminah Robinson Fayek. Let me give a brief introduction to all her illustrious work, and I think that would not be a justice, but let me try. Dr. Fayek has worked with fuzzy logic in her research for more than 30 years, and she's presently working as Vice President, Research and Innovation, and a Professor of Civil Engineering at the University of Alberta. Dr. Fayek earned a Bachelor of Engineering from McGill University in Canada and a Master's of Applied Science from the University of British Columbia. She completed her PhD in Construction Engineering and Project Management at the University of Melbourne in Australia. Throughout her academic career, she has demonstrated excellence in teaching, research, innovation, and partnership. She's a renowned expert in artificial intelligence techniques for developing decision support systems for the construction industry. She has created an internationally renowned research program that has been recognized by a Tier 1 Canada Research Chair and 3 consecutive terms of an NSERC Industrial Research Chair. Dr. Robinson Fayek has received further recognition in the form of many national and international level awards, including a Commendation Award from the International Council for Research and Innovation in Building and Construction, that's CIB, the Purify Construction Research Award from ASCE, and the Walter Shanley Award from Canadian Society for Civil Engineering. Please give her a big round of applause.
So thank you so much, Dr. Hastak, for that very kind introduction. And I'd like to thank Dr. Hastak, Purdue University, and the CIB for inviting me to speak with you today. It is such an honor to be here and to share my experiences. And I hope that at the end, we have some time for feedback and questions and comments. I was just commenting to Dr. Hastak on our walk over here how much Purdue has changed and grown since I came to visit over 10 years ago. So it's really nice to be here once again. So since joining the University of Alberta, I've learned how to combine fundamental and rigorous academic research with applied research. And that's really what I'd like to speak with you today about. I'd like to start by thanking my colleagues in the whole School of Construction Engineering at the University of Alberta, and also just acknowledge the many individuals who've contributed to my research program over the years. And that includes all of my students and my postdoctoral fellows and my staff. And of course, the many individuals at our industry partner organizations who've worked with us and traveled this journey with us, as well as my international colleagues, such as those at Purdue. It's so nice to come back and reconnect with all of you. So I hope that through this presentation, you can see how many people have impacted our research program. I'd also like to acknowledge our federal funding agencies. So the primary funding agency that supported my work is the Natural Sciences and Engineering Research Council that we call NSERC. And as Dr. Hastak noted, the Canada Research Chairs Program. They've supported my program throughout the years and helped raise its profile both nationally and internationally. So I just want to share with you my journey of what led me here today. So I started my engineering career at McGill University in 1986. That's a university located in Montreal in Canada. And some of my career has evolved as a result of taking opportunities as they arose, rather than a very planned or strict approach to how I'd go about things. I chose engineering really based on my love of math without fully understanding or knowing what it was all about. And thankfully, in 1991, I went to the University of British Columbia to do my master's degree in construction engineering and management. And I worked with Professor Alan Russell, who first introduced me to the concept of fuzzy logic, which at the time, as you can imagine, was not well known in construction. After my master's degree, I went to Australia to do some traveling initially, and I ended up in Melbourne, where I did my PhD at the University of Melbourne. And at the time, my supervisors, Colin Duffield and David Young, had been working in industry, and I was their first PhD student. So it gave me an opportunity to work with industry throughout my PhD studies as a result of their background and their collaborations. And that's really what led to my passion for working with industry. I joined the University of Alberta in 1997 as an assistant professor because I'd heard that that was the place to be if you wanted to collaborate with industry, and it certainly was. And Simon Eberizg, who is currently our Dean of Engineering, actually recruited me. And I'm so fortunate now to get to work with him in my new role as Vice President, Research and Innovation. So as you can imagine, when I joined as an assistant professor, if you had told me that 24 years later I'd become the Vice President of Research and Innovation, I would not have believed you. But here I am today. I'm so honored and delighted to be in this role. I get to serve my colleagues, and I get to serve the institution that gave me the career that I have. But today I'm here to talk to you about my research program and why I chose fuzzy logic and what we've done over the past several decades, and then hopefully get some of your feedback on your own programs and your own thoughts. So I just want to start by sharing with you a story from a book written by Malcolm Gladwell. You may have read some of his books, and my favorite one that he writes is called Blink. And he starts the book with a story about the Getty Museum in California, who went about purchasing a Greek statue called a Kouros. And they spent about $10 million, so it was a very significant purchase. Before they made the purchase, they went to the great lengths of scientifically authenticating the statue, getting geologists to do core samples to date it, and they concluded it was authentic, and they made the purchase. Once they put it up on display, they invited a lot of curators and historians, Greek historians, to come and look at it. And a lot of them said to them that it wasn't authentic based on the fact that it didn't look right. And so this called into question the authenticity, and in fact, they took it down from their displays. I don't know if the authenticity has ever been proven definitively. But this story really shows you that a strict engineering approach doesn't always lead us to the right results. And often it's that intuitive experience that leads to a better assessment or judgment of a situation. And all of these internal experts had used their internal computer to make that assessment. So for those of you that are not familiar with fuzzy logic, that story and this slide or this picture really express what fuzzy logic is all about. So on the one side, labeled precision, you see a very engineering mathematical approach to dealing with the problem. But on the right-hand side, you see a more human approach. And although the precise approach is correct, it may not lead to the desired outcomes in time. And often it's that intuitive, quick understanding of a situation that leads us to the right decision and the right results. And that's really the essence of fuzzy logic, is how do we harness and capitalize on all those years of experience and that internal knowledge that human beings developed over time. So classical logic assumes that a statement is either true or false, and that no statement can be both true or false at the same time. So for example, in the construction world, productivity of a crew, a construction crew, and I've spent many decades studying productivity, we know it can be affected by a number of variables, and that includes crew-related variables like their skill and the size of the crew, but it also accounts for the quality of the supervision, the policies in place across that project at the company, and environmental factors like temperature. So some of these factors can be quantified, but some of them have uncertainty that's more subjective in nature. And it's best described using linguistic terms such as high, low, poor, good, and so on. So some of the uncertainty is a result of either subjective uncertainty or resolutional ambiguity. So what fuzzy logic does is it uses the concept of classical logic but expands it. And one of the fundamentals of fuzzy logic is what we call membership functions. And what they allow us to do then is have certain concepts overlap. So here's an example of temperature. And we know, and I'm from Canada, so we use degrees Celsius. So these temperatures are in degrees Celsius. But 23 degrees Celsius, where I come from in Alberta, is considered warm. I know that's not the case everywhere around the world. So it also points to the fact that fuzzy systems are context dependent. But we also know that 22 degrees Celsius effectively is the same temperature. But if you look at classical logic, you have to delineate between the two. Fuzzy logic allows different temperatures to exist to different extents, depending on the amount of overlap between those concepts. So here's a graphical representation of linguistic representations of a numerical concept, which is temperature. So you can see that very cold and cold overlap, as does cold and warm, and so on. And so if we develop a system that uses these concepts, first of all, it's going to be more reflective of reality. But secondly, it will transition more smoothly between states of a variable. So fuzzy set theory then is really a generalization of classical set theory. And it is not about fuzzy or uncertain thinking or logic, which many people think it means. It's actually the fact that the inaccuracy or the fuzziness comes from the fact that concepts can and should overlap. And so the fuzziness doesn't arise from the logic, it arises from the non-sharp boundary between concepts. So for those of you that are in the construction world, you know that that's very reflective of many scenarios in construction. And so it's really, really helpful in solving construction-related problems and lends itself actually quite well to those types of problems. We know in construction, similar to the slide I showed you, that experts have to make quick decisions. And often those decisions are, sometimes they're data-driven, and I'm going to get into a little bit of how we've accomplished combining the data-driven approaches with these more subjective approaches. But they're often based on subjective information, experience, and approximate reasoning. And so that's why fuzzy logic is so well suited to solving construction-related problems. And if we ignore or force such reasoning into traditional approaches, we may not always get the best answer. We know, of course, probabilistic methods have a role, and that probabilistic methods are used to handle statistical or random uncertainty. And so we really are trying to find ways to model uncertainty depending on the tool it is best suited for. So I just want to give you a brief history of fuzzy logic for those of you that aren't familiar with it. And this concept dates back to Dr. Lotfizadeh. He was an Iranian researcher at UC Berkeley. And he was first credited with coining the term fuzzy logic, although there's some stories out there that maybe it existed before that, but certainly he was the one who was first credited with it. And as I mentioned, it transformed the way that uncertainties are modeled, and it gave us a complementary approach to probabilistic methods that handle random or stochastic uncertainty. Fuzzy systems, though, although they were initially maybe conceived of in the US, they took hold much more significantly, first in Japan, and then Europe, and then they made their way back to North America. So one of the earliest commercial applications was a train by Hitachi. And Hitachi developed it to control the Sendai subway and to control the speed of the train. And in fact, this subway, it opened in 1987. It was the world's first train type to use fuzzy logic. And not only was it more energy efficient, but it had smoother starts and stops. So from a user perspective, it was more comfortable. Now, of course, organizations like NASA and Boeing, General Motors, Maytag, Nikon all use fuzzy logic in their applications. And you probably use it every day on your smartphone, on your tablet, in your anti-lock braking system of your car. And as we see more self-driving cars on the road, you'll be using it each and every time you get behind the wheel. Now, in terms of the term fuzzy logic in construction, I've been applying this technique for over 30 years, and it's certainly grown in acceptance in many industries. But in construction, its path was not always clear. And there were many times throughout my career, I doubted, am I choosing the wrong area to focus on? I mean, initially it took a while to get the uptake we wanted. First of all, you can imagine if you tell a construction practitioner, I'm going to use fuzzy logic to improve your decision making, that's not very well received. First they tell you there's nothing warm and fuzzy about construction. And secondly, you're not going to improve my decision making by making it fuzzy. So it takes a while to sort of clear up the fact that it's actually a very accurate mathematical tool to help a computer understand and translate how human beings express themselves. And in fact, it leads to better decision making that is more accurate, especially when we start to combine it with some of the data-driven methods that I'll speak about. I'm glad I persevered. I certainly had lots of encouragement at times to say, just stay the course. And fuzzy logic is a part of the artificial intelligence family. And now, of course, artificial intelligence is popular. It's a household term. It's blown up all over the place. And yet many of us, I'm sure many of you in the room and around the world, have been working in this field for decades. So I'm very glad I persevered. I think it's really paid off, and I hope to share with you some of the things we've been able to do with it. So although I've spoken a lot about the features of fuzzy logic that make it helpful and suitable for construction, it does have its limitations. And in the first part of my career, I was focusing on developing the techniques to adapt fuzzy logic to suit construction. On the latter part of my career, I really focused on fuzzy hybrid techniques, which are trying to combine fuzzy logic with other artificial intelligence, simulation, modeling techniques to really take advantage of the best features of each and overcome their limitations. So one of the limitations that fuzzy logic has is it can't learn from data. And so one of the things we've tried to do is combine it with machine learning and other data-driven techniques to bring in the fact that now in construction, we do collect significant amounts of data. That was not always the case. So data limitation was certainly a barrier in the past. It's no longer the case. So as I showed you, because the fuzzy logic systems alone are based on expert knowledge and they're context dependent, the example I used in temperature, they can't always be adapted to suit different industries, different sectors, or even different projects within a given sector. And so in order to overcome that limitation, we have basically started hybridizing it with other techniques. So one of the most promising developments is really combining fuzzy logic with machine learning techniques, such as artificial neural networks, but also with optimization techniques, such as evolutionary particle swarm algorithms and evolutionary and particle swarm algorithms, other optimization techniques. When you start combining these techniques together, you can leverage the strengths of individual ones. So the fuzzy component accommodates the subjective variables and also the expert reasoning. The machine learning component automates the development of the system. So you don't have to develop every rule, every membership function manually. And because we now collect significant data sets, it makes machine learning more feasible and more accurate, because we know that machine learning is only as good as the data set on which it's trained. And in construction, that used to always be the limitation, not so much the case anymore. And then the optimization component, of course, calibrates the system to improve its parameters. So we've used these combinations to address everything from motivation to construction project productivity to construction performance. And also we're applying it in organizational and project competencies. So I want to talk a little bit about productivity. Productivity, of course, is a big concern for our industry and many others, and many of us have studied it using different methods. One of the biggest challenges in modeling productivity, whether it's to predict it or manage it during project execution, is there's a multitude of factors, as I mentioned, at all levels that interact to result in a given productivity. And that includes the individual level, and that's where motivation comes in, crew dynamics, the crew level, the project level, and the organizational environmental level. So it's very difficult to create an algorithm that accounts for all of these factors. Some of them have random uncertainty, and some of them have subjective uncertainty. So using statistical methods alone is certainly challenging. So what we've done is we've collected a lot of data on sites to try and model and quantify all the various factors at different levels. And we've used fuzzy C-means clustering to develop fuzzy rules to model these complex relationships and behaviors. We also combined it with genetic algorithms, which is an optimization technique, to really help us not only improve the accuracy of our models, but make them more interpretable. And interpretability or transparency in a model is very important for users, experts, to actually rely on it and trust it. And so while they don't need to necessarily know the algorithm, they need to understand the reasoning that this model is giving you. And that is a challenge with some of the machine learning models, because they tend to be black boxes once they're trained. We also applied fuzzy multi-criteria decision-making techniques to help us narrow down the multitude of factors and really focus on those that we wanted to model and optimize. So in order to do all this, we really, that's why the program has really evolved into fuzzy hybrid techniques, is found ways to combine these techniques effectively. And as I mentioned, we then expanded it to look at competencies of teams, competencies of projects, and organizational competency. Now, I know there's a lot of simulation experts in this room, and I know that there's great expertise here at Purdue in simulation and at the University of Alberta. So one of the things we also know is that we have to look at construction processes that change over time, and simulation is an ideal tool for that. I always say our lab is the construction project itself, it's the field. So simulating things is really our way of creating a lab, a synthetic lab, before we go out there and actually execute the work. So we know that in traditional simulation methods, we rely on probabilistic modeling to handle the uncertainty. And so what we've tried to do is incorporate fuzzy methods to account for the subjective uncertainty alongside the probabilistic methods and incorporate them into simulation models. So we've done this with Monte Carlo simulation, discrete event simulation, system dynamics, and agent-based modeling, depending on the problem we were trying to model. So agent-based modeling was used to try and model crew motivation, because of course it allowed us to model things at the individual level. We've used system dynamics to look at productivity at a slightly higher level. And of course, discrete event Monte Carlo simulation. I'll talk a little bit about Monte Carlo, that we've developed methods for risk analysis. And of course, discrete event is great for modeling construction processes. So what that allowed us to do then is create more realistic process models by combining the various forms of artificial intelligence techniques with the simulation methods. So we've applied this, of course, in productivity. That allowed us to take labor productivity and expand it to include other things, other resources such as equipment, materials, and explore changes of productivity over time using a systems approach. We also have used it to, as I mentioned, to model things like organizational competency. And one thing that we've done is, just like you have traditional arithmetic, there's fuzzy arithmetic. And so we've been able to process subjective variables using fuzzy arithmetic methods to incorporate them into our models. So our next step in all of this is to ensure that we can simultaneously process both fuzzy and random variables in simulation models, and also incorporate some of the fuzzy machine learning and fuzzy optimization techniques into those models. So I want to share with you a very practical application. So as I mentioned, I benefited from many years of industrial collaboration through my NSERC Industrial Research Chair program. And some of these companies have been with me for over 20 years. So Capital Power is one of our companies. They're a very large owner organization, and they construct power generation facilities. And they've used natural gas. They've used coal, although, as you know, in Alberta, we're phasing out coal, so we're moving more towards natural gas. But they also do a lot of wind power, and I saw that when I was driving in, that is also very common here. Risk analysis is core to what they do. So they do this as an owner organization. They do it in the planning stages, and they also do it quarterly through project execution. They were using Monte Carlo simulation for this. And one of the challenges they were facing is developing the probabilistic distributions to feed into the Monte Carlo simulation. One of the reasons is, believe it or not, we still have a lack of adequate historical data in construction. We know that projects are unique, so to collect enough data to make these distributions robust is a challenge. So what they were doing, which I think a lot of organizations do, is they were actually relying on their experts to choose the probabilistic distributions. So a couple of things with that is, first of all, that isn't the essence of a random distribution. Secondly, it was really challenging to get all these experts to meet at a given time and to incorporate their different levels of expertise and reach consensus, because you can only choose one distribution at the end of the day. But very importantly too, they were finding the experts were spending all their time trying to pick the right distribution rather than truly looking at what are the risks and opportunities. And they wanted to account for both risks and opportunities explicitly rather than incorporate them together. So we spent many years actually working very closely with them, and the outcome is a software tool that they've now replaced their Monte Carlo simulation with. It's called Fuzzy Risk Analyzer. It used to, in its first instance, it was called Fuzzy Contingency Determinator, but we've expanded it now. And what we're allowing them to do is they can now assess both risks and opportunities in terms of these linguistic terms of high, medium, and low. But more importantly, they can calibrate the terms depending on the project and also depending on the user's perspective. So every user has a different risk tolerance. So we needed to find a way to calibrate that. The other thing we did is we developed a fuzzy multi-criteria decision-making approach to weight their experts depending on their levels of expertise. So rather than have to combine all their opinions and reach consensus, we can now account for every individual's perspective, but weight them according to their level of expertise. And we can give them a value based on risk and opportunity, and then allow them to combine that to come up with an overall contingency number, because we know we tend to weight more heavily on the risk side than the opportunity side. So we can now make that very explicit for each and every risk factor and still come up with the traditional contingency distribution that they might need to choose a number within a comfort level. So for a while there, they ran our software tool in parallel to their Monte Carlo simulation tool, and that's good practice. You wouldn't want to abandon something in favor of something else until you've tested it. But over time, they found that our tool not only gave them comparable results, but it narrowed the range of uncertainty. And that freed up contingency reserve to use on other projects. So they've now fully adopted our software tool. Because we work with a lot of industry partners, many of our industry partners, some of whom are contractors, some of whom are owners, some of whom are labor providers, they were quite interested in this. So we generalized it to take away any company corporate specific information, and we created a general tool that we provide through our program free of charge to our companies so that they can use it more broadly. And this is just one example of, although it is a theoretical field, it's actually has a lot of very practical applications. And that's really what motivates me, is how do we take the great state-of-the-art, the science, and apply it to solve real problems. So we've applied this technique, as you can imagine, over 30 years to many different areas, and these are just a few of them. You can see that it can be applied to so many different aspects. I even did a collaborative study with a colleague of mine who's in water resources to look at predicting runoff from our ice melts. So it's also applicable in many different fields. One thing that I hope we've done is we've been able to take these techniques and adapt them to suit the characteristics of the construction domain. And that is really important, because no matter what we do, we have to look at what makes our industry unique, and how do we adapt tools to make them suitable and more effective. We've developed systems that are more readily accepted by practitioners because they're transparent, they give them good results, but they match their approach to decision making. Also, very importantly, we have more experienced people leaving the industry than entering it. So what these tools also do is they help document and capture that expertise. So it can also be used for training the next generation. And also by applying or transferring what we've done to those that are using it on the job, hopefully we've helped to contribute to the level of innovation in the construction industry as well. And through that, shaped some of the construction practices that are being implemented. So Dr. Hastak mentioned my Canada Research Chair, and that's been one of the highest honors I've received in my career, a Tier 1 Canada Research Chair. And as you see the name, it's called Fuzzy Hybrid Decision Support Systems for Construction. So it really is focused on the integration of a lot of these techniques. And what we're working on is a framework of software tools that will support construction management decision-making at multiple levels. That includes, of course, the activity level, the project level, and the organizational levels. And through the combination of these techniques and tools, we're hoping to model a variety of project management functions. So that includes scheduling, estimating, risk analysis, project management processes, and the physical construction of projects. We've also created a data warehouse. We've been collecting data for decades, both numerical and subjective data. And that data warehouse is really the engine that feeds a lot of our applications. And when COVID happened, it was tough for all of us. One of the things we couldn't do is go and collect new data. So we actually spent a lot of time working on this data warehouse and looking at what else we could do with the significant data sets that we did have. And of course, we're helping industry to digitalize a lot of their functions and processes. I was sharing with some of your colleagues at breakfast the exciting new area that we're pursuing, and I know that at Purdue there's several faculty members that I hope we can collaborate together on this. It's looking at how we collect and analyze behavioral data. So traditionally, we've used indirect methods such as interviews, observations, questionnaires, to try even discussions, group discussions, to collect all the data that we need, particularly when it comes to behavioral data, emotional states, motivation levels, all the things that we use to model productivity and motivation. Now we know that there's more advanced methods that look at physiological data. And this physiological data can be used actually, and it's been used in other disciplines like psychology and like business, biomedical engineering, to actually have direct ways of determining human emotions, fatigue, reactions to the environment. And it's got a lot of applications in safety and productivity in other areas. So this is really what we're working on now. We've created a new lab that has a lot of the sensors that we need to collect physiological data, biosensors, physical sensors, exoskeletons. And we're working with experts in neuroscience and in psychology to see how we can analyze it, collect the data, analyze it, and then use it to actually feed some of the models that we used to have to go out and collect data for using indirect methods. So we're pretty excited about that. I know that there's been great advances made, and we're looking forward to that collaboration. So I want to start by speaking a little bit about the industry collaboration. And these are only some of the companies that have been with me for decades, and I'm so grateful to all of them. I wouldn't have been able to establish this program without their partnership. And these organizations have allowed us into their companies. Our students go there, they get that experiential work integrated learning experience. They work hand in hand with the organizations. They go out onto their job sites. And these companies have traveled this journey with us every step of the way. They're true partners in what we've been producing. They help us define the problem that's relevant to them, but they also really work with us in terms of the implementation. And as I mentioned, these partnerships have been facilitated by my NSERC Industrial Research Chair, which I've held for 15 years, and that's a federal funding program, and also my Canada Research Chair. And what's unique about it is we have companies who are normally competitors in the industry come together. We also have owners and contractors and labor organizations. Often these relationships, some of them are smooth and some of them are not so smooth. But by coming together in this collaborative environment and trusting us, allowing us to be the objective third party, we've been able to solve larger problems that have more significance and more impact on the construction industry as a whole. as well as meeting the individual needs of these organizations. And this has led to a lot of long-term sustained funding that's allowed us to focus on these initiatives, and also helped us address the most relevant issues facing the industry. And when I put up the slide showing you the different applications, those applications have changed over time, depending on what are the most pressing issues facing the industry. We've also helped contribute to a culture of university, industry, government collaboration. And that is really the basis of what many of us do at the whole School of Construction Engineering. It really is about being outward focused, but we know we can't solve the big problems without industry and government coming to the table with academia. And very importantly, we've tried to bridge the gap between academic theory and engineering practice. And that's something that all of us, I know, care very deeply about as engineering researchers, because we are wanting to serve that industry. The other thing we've done is helped members of these companies advance their own careers, because they get trained in the state of the art, they can implement the state of the art, and many of our students who work with them get hired and transfer their knowledge directly to these organizations. The other thing, and I'm going to talk a little bit about challenges we all face as researchers, is very importantly, we've found effective ways to translate our research to practice. And so I gave you an example of the software developments. That's often the most effective way. But we've certainly spent a lot of time doing workshops, technology transfer workshops, but writing reports that aren't academic in nature, but are really a how-to user guide that's been more valuable and useful to industry, even though we don't necessarily get the academic credit for that. And I'm going to talk about challenges and opportunities. One of the most exciting things I was able to participate in was I served as the editor of the first ever book on fuzzy hybrid computing and construction engineering and management. And this was published in 2018 by Emerald. I was able to, fortunately, bring together 32 researchers from 11 different countries to discuss the state of the art in fuzzy hybrid modeling and construction, and also the variety of ways and industries they've applied it to. This collaboration and sharing of ideas between researchers has created a critical mass and a community. And hopefully over time, this critical mass of researchers will continue to build as new faculty members join the community as we grow this space. Obviously, this is a snapshot in time, and we need to continue to evolve and update, and hopefully someone else will come along and advance this book. But having this community of researchers who work in fuzzy hybrid techniques in construction is really going to help us advance the field. And many of the authors wrote about their own experiences working with industry and solving their problems. So I just want to spend a bit of time talking about challenges and opportunities before I open it up to your thoughts. And I think these challenges and opportunities are faced by all researchers. One of the things I think we all face, or at least I face, is making sure that I translate research into impact and measuring that impact. You know, we as construction researchers have created a very large body of knowledge. I mean, look at the amazing archival journals we published, decades worth of work, researchers that build upon other researchers' work. And yet sometimes our impact isn't in proportion to that huge body of knowledge. And I think there's a number of reasons for that. The first one is the different timelines. Industry operates on a much shorter timeline, wants a quicker return on investment. We have to train our students, we have to collect the data, we have to solve the problems in ways that take longer. And so part of it is understanding how to meet the short-term needs or demands of industry and show return on investment, and at the same time maintain the integrity of the research process and ensure that we are also training the students who then go on to become the leaders in academia and industry. I talked a little bit about reward systems. That's certainly something in my new role I'm even more focused on, is the academic reward system does not always reward technology transfer, innovation, commercialization. I know at the University of Alberta, we're looking at that very carefully because we want to advance our innovation and commercialization and technology transfer. But it's not just a university problem. We know it's an international problem, because when our faculty go out for tenure and promotion, we also know that peer review is very, very important. And so the reward system isn't always favoring the application piece of the work that we do. And many of us have done it out of a love for doing it rather than the fact that we're going to get the academic credit for it. Although I truly believe the two are intertwined to produce really high quality academic work. What you learn by working with external parties is critical to that. And thankfully, our federal government recognizes that and has many partnership funding programs that translate into industry dollars into many more dollars. The other thing is construction industry practitioners are facing information overload. And so they need more manageable, succinct, easy to understand ways of translating our highly academic theoretical work into practical methods and tools that they can use. So here's a few ideas, and this is why I want to open it up to your own. So we know we have great academic journals, great archival knowledge, top-notch peer review system. But we could, for example, create companion journals that are much more applied. And by that, I don't mean that you have to do more work to publish 2 types of papers. I mean allowing academics who've published in a top-tier journal to take that paper, translate it into a more applied version of that paper, and publish it in this practice journal. And it can be a companion journal to one of our top-tier journals. And it gives us as researchers the ability to take what we have to do anyway to translate it for industry and be able to publish it for our community and start to learn from each other on what that looks like. The other thing is training of our products, training industry in practical ways, having workshops, ensuring that there's a real hands-on deliverable is really important. And the workshops we've held where we've literally sat them in front of a computer with the software and done a training workshop is what's led to the best results. It's often given us the ideas of how to make things better by having the users right there. Applying things on demonstration projects is quite critical because that really helps show the value, and maybe creating some experimentation where we have demonstration projects around the world, different locations where we're trying to test out these ideas. If we collaborate on something and we come up with a result, let's try it here in the US, let's try it in Canada, let's try it internationally and see what that looks like. And then one of the things I'm working on, certainly in my office, is improving our intellectual property policies. So we need to try and simplify how intellectual property is shared. We need to encourage more openness in terms of IP. And at the same time, we need to simplify our own policies so that we encourage entrepreneurship. We encourage students and faculty members to start spin-offs and startups and licenses and patents. So we're very focused on looking at our own internal IP policies and how we can make them more user-friendly, not just for the external parties, but for our own people who want to take their IP and apply it into ways that are more commercial in nature. Interdisciplinarity, I spent a nice morning with many people at Purdue and have another afternoon planned, and we talked a lot about interdisciplinarity. We know that the grand challenges of our time can only be solved through an interdisciplinary approach. And yet we know how challenging it is to create true interdisciplinarity, even multidisciplinarity. And so it's really important that we focus on how we build those networks, how we collaborate, not only within our institutions, but across institutions. And we also know that these collaborations only work if there's a complementarity of skills, but also a shared set of values and objectives. So one of the collaborations that my team has built has been with the Alberta School of Business, and that was in the area of motivation. We went to the experts who are developing the motivation theories, who brought us up to speed on these are the motivation theories, the modern motivation theories. And of all of them out there, these are the ones that are most suited to construction. So we established that relationship years ago, and we continue to work together so that we can bring in our expertise in construction with that of business. And as I mentioned, we're now collaborating with people in psychology and neuroscience to take our work and expand it. So collaboration has been very beneficial, But it's important that we have funding mechanisms that support interdisciplinary, multidisciplinary collaboration, including the development of strategic networks and networks that require different disciplines to come together, different faculties, departments, colleges, but also different institutions, because our contexts can be quite different. We collaborate with people in South America, we collaborate with Mexico, we collaborate with the UK, we collaborate with countries in Africa and Asia. Every context can be quite different. So it is important also to extend it beyond our own environment. And the other thing is industry academic partnerships, which are underpinned by long-term sustained funding, are also very beneficial for creating impact. And finally, funding people, not projects. If you fund people, they can focus on the work. If you're funding projects, then you're constantly applying for new grants. And so that's where I think NSERC has done a good job in terms of creating longer-term programs that allow us to do that. I want to touch a little bit about service, because when I talked about impact, we shouldn't underestimate the impact we can make through our service. And we can do that whether we serve our profession, our industry, or our community. It helps us become better researchers. We're more aware of the issues at large. And at the same time, it creates opportunities for us to formally and informally disseminate our results. So I've had the opportunity throughout my career to serve on editorial boards, participate in academic, industry, and government review committees, and conduct outreach activities. So there's some of my outreach activities and service work. I've enjoyed so much being on the editorial board of the Journal of Construction Engineering and Management and the Canadian Journal of Civil Engineering. And I've learned so much by overseeing manuscripts from so many diverse areas, but very importantly, learning from my colleagues, learning from the editors and the associate editors and the assistant and specialty editors. I also had the opportunity to serve on an NSERC committee that looks at university industry grants. And that was really beneficial for me as well, being in this area. And I was fortunate to be a joint coordinator of one of the CIB task groups on R&D investment and impact, which was a great experience. I also enjoy doing outreach. I visited elementary and secondary school students and certainly focused on promoting engineering as a career, especially to women who we're trying to increase participation of women and other groups in the STEM fields. One of my greatest honors has been being appointed as the Vice President of Research and Innovation since 2021. And in this role, I now have the opportunity to serve my entire university community. It's also been a real privilege to be able to contribute to the larger national and international research and innovation ecosystem and help shape some of the policies and practices that are impacting our researchers. I've learned so much, of course, by working with the different disciplines. And I brought a copy, I've given it to some of your colleagues. One of the most exciting things is we launched our very first pan-institutional strategic plan for research and innovation. It's called Forward with Purpose, and you can certainly find it on our website. And what's really exciting about this is it covers all the disciplines. It's for the entire university. We did a lot of consultation to ensure it was very reflective of our internal and external communities. And it gives us not only an architecture, but also a blueprint for how we're going to achieve our research and innovation goals over the next 5 years. So with that, I just want to thank you for being here today. I want to thank you for the invitation to come and speak with you and the opportunity to share some of my ideas. Thank you again, Dr. Hastak and the CIB in Purdue. And I hope that some of my thoughts are beneficial to you. I hope they lead to some discussions, and I would really welcome your questions or comments.
That was indeed a very interesting presentation. I'm sure there are a lot of questions awaiting. So anybody who wants to go first? Anybody online? We have audience online. Oh, there's one. Yes, Jalsi, please go ahead.
Always like
yeah.
start my questions. Thank you for a very inspiring presentation, Professor Fayek. And I think I've known you since you started off, and both of us were faculty members. Okay.
So I was very fascinated by the route that you have taken to be here and your engagement with industry and having an impact. So it's not just papers, but what are we doing to translate what we have done in our lab setting into the field, and what impact does it have? Now, one of the major groups that you have, or stakeholder groups that you have in the Alberta area, is Indigenous people, Indigenous communities, right? And so I just wanted to hear your perspective, from a research, from the perspective of a researcher / educator, and now as an administrator and someone who's setting the research landscape for the university, as to how you are engaging with and involving the Indigenous communities.
So that's such a great question, Dr. Abraham, and it's true, we go way back. I think Dr. Abraham was one of the first people I met when I started my role as an assistant professor. Your question is a very important one, and certainly since coming into my role as Vice President Research and Innovation, it's been one of the most important things I've had to learn about and think about. And so I'm very fortunate because we have a Vice Provost Indigenous, her name is Florence Glanfield, and she's really helped me learn and understand what it means to effectively engage with Indigenous communities. So one thing I've done in my office is I've hired 2 new positions. I've hired several new positions, but 2 of them, one is a research officer in equity, diversity, and inclusion, and one is a research officer in Indigenous initiatives. And that Indigenous initiatives research officer is Indigenous. We also have one of the few faculties of Native Studies on campus, but we have Indigenous scholars working in every field. One of the things I've learned is that how Indigenous organizations or Indigenous communities think about research. And it's not about us going to a company and saying, what do you want to work on, and let's do it. It's about co-creation. It's about first learning what about the community, about what are the issues, but it's about co-defining and co-creation in doing it in a very respectful way. And certainly we've, as the University of Alberta, are committed to truth and reconciliation. We have a lot of Northern and Indigenous communities. So I'm still learning in that space. I'm lucky that I have people on campus who are much more experienced and knowledgeable, but I'm really starting to understand what it means to work with an Indigenous community. And we've also engaged quite a bit with government groups that focus on Indigenous communities. The other thing is, we've got a strategic plan called Braiding Past, Present, and Future, which is our first institutional Indigenous strategic plan. And there's a very large research component. So when we develop our strategic plan, Forward with Purpose, you will see woven throughout it that respect and consideration. And also one of our focus areas is Indigenous research. So it's a very important question, and one that for me, I'm on a learning journey, as I am for many things, because when I came into this role, I'm still learning about all the various disciplines. So thank you for that question.
Thank you.
Thank you, Professor Abraham. Do we have any other questions coming up? Yes, please, go ahead.
Thank you very much. It was very interesting and reminded me a little bit of some of my graduate work in expert systems. But my area right now is in facilities engineering and management, which has many challenges associated with all the different driving factors and those issues of affecting people, place, and process for facility management. And I know I frustrate some of my students when they ask me, well, what's the answer? And I frequently say, well, it depends. What kind of research opportunities do you sense, or are there others who are active in fuzzy research as it would apply to the existing built environment rather than the construction environment?
Yeah, so that's a great question. And by the way, I'm glad you said that you worked in expert systems. Expert systems have been in place for a long time, and that's another artificial intelligence technique. So as I mentioned, many researchers have been doing this for decades. So yes, 100% your point, and I love what you said, it depends. Actually, that's the context dependentness of many of our solutions. So on the maintenance side, facilities maintenance, We have what's called the Future Energy Systems Project, and I have a project that's in collaboration with other colleagues. And it's not only about construction, but it's also about the maintenance and life cycle of our facilities. So everything I talked about equally applies on the maintenance side, and there's many researchers working on that. And in fact, in Alberta, because we have large industrial facilities, maintenance and turnarounds are an annual, if not semi-annual process. And so the costs, the scheduling, the risk analysis, the productivity, the motivation, all the things that apply in construction now apply in a much shorter timeline for a maintenance project or a turnaround. And so fuzzy logic and many of the techniques I talked about are equally applicable, simulation, because it's the same issues. We're just trying to model them in sometimes a compressed timeline or a different context. So yes, there are many researchers that are working in these areas, in the maintenance side as much as the construction side.
Thank you, Professor Widener. Any more questions coming from the audience here? Well, let me throw in my question then. So very, very interesting presentation, as I mentioned. I was wondering, as you were making your presentation, that with the emphasis on Industry 4.0, Construction 4.0, and now Industry 5.0 and also 6.0 coming up soon, how do you see fuzzy logic being applied to better incorporate technology from the 4.0 side of view and more from a human-centric side of view in 5.0 and so on? So your thoughts, please.
Yeah, that's a really good question. So I think the advancements we've made in terms of technology are very, very significant. I also think that the industry has moved much more towards digitalization of processes, automation of processes. We were talking earlier about architecture and how now it's even moved into more of the digital architecture. We also collect massive amounts of data now with drones and with all of the sensors, even in equipment, with sensors that people wear on site, with So there's so much on the technology side. But we know that the technology won't be effective unless, first of all, we synthesize all that information. We account for the human element in everything that we're doing, because at the end of the day, humans are the biggest part of any construction project, even though we have big equipment and automation. But also, we have to train people, and we have to gain acceptance of human beings in adopting and using these technologies. And so fuzzy logic and subjective uncertainty and expert reasoning still come into play in all of these processes. The nice thing now, though, is we've moved more towards automation. We have more data, so we can really improve expert systems and fuzzy logic by harnessing the power of the data-driven methods, of the optimization. But things are more complex as well. And so with complexity it goes back to my original comment about the need to incorporate faster, more experience, decision-making that incorporates some of these, the know-how that people have to handle all that complexity, because our algorithms and traditional methods and statistical methods can't model all that. So I think there's even more of a role for some of these techniques as we become more advanced, as we get more data, as we automate technologies more. And always the human interface to anything is, at the end of the day, what will make something effective.
Quite right. I completely agree with your comment there. Let me reach out again and see if our audience has any questions boiling up. Anybody online? There are a couple of hands raised up there. So Sean, go ahead, please. You're on mute, Sean.
Hello, Professor. My name is Kyung-Seok Lee, but I go by Sean, and currently I'm a PhD candidate in Civil Engineering Department. First of all, thank you so much for your inspiring presentation. So I have actually two questions from your presentation. So the first one is, during the presentation, you talk about the entrepreneurship and encouraging the commercialization process. So as a PhD students, I have had a privilege of joining NSF ICOPS program to commercialize my research outcome. So during the ICOPS program, I have observed that some research outcome fail to translate into the practice because they have like limited understand or they misunderstand some industry's needs. So are there any strategy that we can adopt during the research development process so that we can successfully translate our outcome into the practice, ultimately expand our outcome?
So Sean, thank you so much for joining online, and I really appreciate your question. You ask a very important question, and congratulations to you that you've, are part of this program and you're trying to commercialize your work. So a couple of things that I've learned about commercialization, because I've done a little bit myself, but quite honestly, what I have found is that it's easier to co-develop something than to try and launch it after the fact. So Sean, one thing that has benefited our program is we actually start working with industry before we undertake whatever it is that we want to develop. So we almost start with the end in mind. And it's not a quick process. So the work I presented, the software that we developed for Capital Power, we started with a preliminary conversation when they said, this is the problem we're facing. What can you do to bring to bear on the problem? And we actually worked hand in hand with them as we were developing our solutions. We had many interim solutions that were tested. They gave us feedback. So it was very iterative. So by the time we got to the finished product, it was as much theirs as it was ours. And so they adopted it naturally. Now, I know with commercialization, there are IP issues, and certainly you want to share IP fairly when somebody co-develops something with you. But I think that in your case, if you can do some pilot testing, if you can try things out in real settings before you get to that final stage, if you can get people to buy in and help you sort of co-develop before you get to the stage where you want to launch it, I would guess that the uptake would be a lot easier. Now, then you have to deal with the sharing of IP and ensure that it's done, appropriately for co-creation. But certainly having a partner on board almost before you start, and maybe not quite that early, you need to develop the core yourself, but having that, the person who's going to take it on or uptake it with you in the journey would help your uptake. So I don't know what your application is exactly, but certainly we've seen that the most helpful in terms of disseminating our outcomes. There was the odd time where we developed a piece of software and a company came and said, we really like this, can we license it? But that was one set of, how many things we've done. So that would be my advice to you.
Thank you so much. Thank you so much for your answer. And as I mentioned, I have another question. So even though I'm not the expertise in the fuzzy logic, I feel like it is very similar to the Bayesian probability, because Bayesian probability also talking about the uncertainty probability of like something happening, and also it used the prior distribution of the data. So what are some difference between fuzzy logic and Bayesian probability?
Yeah, that's a great question. So there's a lot of similarities, and certainly they are both to some extent trying to do similar things. With the Bayesian probability, it can incorporate subjective knowledge, and certainly that can be incorporated in it. I think the fuzzy logic, though, it's such a broad field that it is applicable. There's many different tools in the fuzzy logic family that can do things also beyond that. And also, fuzzy logic is not based on randomness or probability theory. It really isn't. It's really based on subjective uncertainty rather than random uncertainty. So it actually has its place with Bayesian theory, with probabilistic theory. So they can be complementary, and at times they can try and do the same thing. But fuzzy logic, I would say, is a larger family of techniques, and you can use it for many different applications.
Sure. Thank you so much for your answer.
Thank you.
Thank you, Sean. Let me again reach out to our resident audience here to see if anybody has a question. Yes, please, Majid. Go ahead.
Thank you for the presentation, Dr. Fayek. So currently I'm working on a research where I'm trying to predict workers' productivity and how the heat stress affects labors. So I ran into some issues, of course. So you mentioned that productivity can be affected by many factors, such as fatigue, weather condition, and all of these factors. So if we were to prioritize these factors, based on your experience, where should we prioritize these like factors, and how to distinguish between these factors when we try to create a model for that?
That's a very good question, and that's why I think researchers have been working on this problem for decades and will continue to do so. So we've done some studies to try and rank factors that affect productivity. And I'd have to go back and relook at those, because we generally will pick 10 to 12 factors. They aren't independent, to your point, and so that's where the complexity comes in. So environmental factors rank up there, and there's quite a few of them. So whether it's temperature, whether it's the wind, the environment that you're working in. The other big one, though, is not only crew skill, but motivation. And motivation is complex because there's concepts around self-efficacy, how you believe you could do the work. There's concepts around the skills that you possess to do the work. And then there's concepts simply about the crew dynamics and how that affects motivation. But the one thing that really stood out in my mind was the supervisor's impact on the crew. So the competency of the foreman had a big role in terms of the crew's performance and productivity, and then the crew composition, the crew dynamics. The other thing that often comes up is the work environment. So I don't mean by the physical environment, but the organizational environment that affects a crew. So I can certainly, after this lecture, get your information, send you a few of the studies where we've tried to get really specific on what are the major factors, how do they interact. And then the only thing I'll say is you'd almost have to run these models again in your context and see if you get similar results. You'll probably get some that are very common, but it is incredible how, depending even on the relationship between the owner and the contractor, how competent the organization is, it can have a significant impact on productivity. And so that's why we've tried to take it up to we've studied it at the individual and crew level, at the project level, but also at the organizational level. What makes an organization competent that then makes a project competent, and therefore the crew. So I'd be happy to share some of those with you. I wish I had a single answer for you, but there's quite a few factors that interact to do that. But certainly the people side, the environment, and then how well the project and the organization are managed or run.
Thank you, Madeline. Well, let me go over to Dave Devine. I saw your hand go up earlier. Go ahead, please.
Sure, thank you. I was curious about you mentioned how publications, and there's the academic publication, and then getting information out to industry. Are you talking about something different than industry magazines that are full of ads? And then I was sure if I could sneak another question in there. Many of we're students. You identified how some of this terminology might just not be welcome in construction companies. Could you maybe speak to how a new graduate or somebody working in the summer might bring up some of these topics on the job site or in the construction company that they're working for?
Yeah, Dave, thank you for joining online, and those are excellent questions, and I see you're an industry practitioner, so I really value and appreciate those questions. So with the first one, yes, I am talking about something. I mean, the Engineering News Record is an excellent publication, but I'm talking about something sort of in the middle between an ASCE Journal of Construction Engineering and Management and the Engineering News Record. And it is about practical, maybe 2-page articles on, here's the piece that is a 10-page theoretical article with all the calculations and all the steps, and here's what you can do with that, and here's the steps you can do with it. So it isn't as much in the vein, I mean, ENR, I read ENR, and I love especially the legal cases, and I love that practitioners write in there, but I'm thinking more along the lines of something that academics could co-author with their industry partners, and it could basically be, here, I've published the academic piece, what would industry see a value from that? And then industry could be the lead author on that and basically write that article with the researcher. I don't know if that exists. At least the last time I was thinking about it, it didn't. It may. If it does, I think it would be great for us to highlight or elevate it. But I'd like to see our academic journals create companion journals that go hand in hand and that researchers can get credit for both the academic piece and the applied piece. And I know the Journal of Construction Engineering and Management has a forum to do that. And it's really taking that forum concept and expanding it. For the student one, that's a great question. And I would say that the biggest thing we can do to help our students is help them on the communication side. Help them to be able to translate their work in a way that's meaningful to industry. I don't need to go and use the term fuzzy logic, right? Although now my industry partners use it, and I'm so happy about that because they've worked with us for so long. Not only do they understand it, but they like it and they use it themselves. So to me, that's the biggest thing we can do is get them using the terminology. But I think when a student goes out, they need to speak in the language that makes sense for whoever is receiving it. And it could be industry, it could be a community member, a government partner, but you don't need to use fuzzy logic. You can just say, I want to translate your expertise and know-how into a system that harnesses that and allows you to collect different opinions and actually make better decisions. So part of it is training our students on how they don't need to use the terminology that we use. They can actually explain it. They need to learn how to explain it in a way that makes sense even for the public. So part of our job is teaching them, taking them to, a lot of my students not only present at academic conferences, they go to industry conferences, and the Construction Owners Association of Alberta, which I should have mentioned at the beginning, they were my first industry partner. They're all the big oil and gas companies in Alberta. They have like 400 members, 500 members. Every year we go to their event, we have posters. The students stand in front of their posters and have to explain to industry how their work is relevant. And so part of it is training our students in how they should explain their work to an industry audience by sending them to events where it's primarily an industry audience, not an academic audience.
Thank you, Dave, for that question.
Thank you.
Did you have a follow-up on that or no?
No, just thank you.
Okay, great. Thank you. Well, we have a question here. Arka, you had your hand raised. Go ahead, please.
So yeah, great presentation. Thank you for sharing your experience and wisdom. So I want to know one thing. So you said that you have been working with fuzzy logic for several decades, right? So in the meantime, you have improved, you have incorporated the data-driven techniques, the optimization algorithms, and the advancements in other methods. So my question is why, I mean, when you started working with fuzzy logic, did you see yourself as, I mean, you'll be working with the same methods or improving this method after, after these several decades, and what made you, stay with this fuzzy logic over your expansive career?
So thanks for asking that question. When I started working in fuzzy logic, I think it was in 1991 when I started my master's degree. So a lot of these methods were not advanced enough yet, and I was a master's student, so I don't think I had the foresight to think down the road I'm going to work with all these different artificial intelligence techniques. I remember at the time there was fuzzy logic, neural networks were just starting, and certainly expert systems existed. And so when I started, my master's supervisor and we chose fuzzy logic to model a scheduling application. And I heard about these other techniques, but I was very focused on that. Certainly not yet really understanding its limitations. Then when I did my PhD, I did on bidding strategies, and once again, incorporated fuzzy logic. Of course, over time, a lot of the other techniques that I've talked about were also evolving, right, at the same time, and they became prominent. And as a researcher, by doing research over decades with students, of course, and I started to come up against limitations of my own research. And I said, hang on a second, this can only take us so far. And now that the state of the art has advanced in all these other areas, we need to start looking at them. So I wouldn't say that I knew at all at the beginning. I didn't anticipate that. It's an evolution over time. And as things develop, I hope that we can continue to develop our thinking. Why did I stick with it? I remember having this conversation at one of the ASC conferences. I think it was in Virginia. My master's supervisor was there, and I was at that stage in my career thinking, I think I picked the wrong area. I just don't think there's uptake here. And he said to me, he was great. He said, Aminah, you got to persevere. He was in a little bit of a different area at that point, but he said, we persevered for years. And then finally, the topic was accepted by our industry partners, and it took off. I'm so glad he gave me that advice, so I stuck with it. And another piece of advice I got from my colleague Simon Abarisk is, he said to me, pick an area early on and stick with it, and don't be a butterfly. So yes, I have at times done a few other industry applications, but you got to develop your core expertise and keep pushing it until you become an expert, until you become recognized as an expert. And that can take years. It's not going to happen in 5 years. It'll take you a decade probably to become, renowned in that area, and then continue to become renowned until you're internationally recognized. So my advice to you is the same advice I got. Pick an area, stick to it, become a real expert in it, be versatile, adapt as you go, but have a core focus. And I love that advice, don't be a butterfly. And it served me well.
Well, now you have a threefold advice. You have Professor Fayek, Professor Abarisk, and Professor Alan Russell. So there you go.
Yeah.
Thank you very much. Any other questions from the audience? Well, it looks like we are running out of time. So let me throw in my last question, as I always do. And that is that you mentioned about, some of the IP issues that you're finding. And so my question was that, what are some of the IP issues you're finding in construction that are coming your way?
Yeah, so that's a really good question. I mean, I'll talk about how I was as a construction professor versus what I see now, because I think, so as a construction professor, we generally license things, there are patents, certainly some of us develop patents, but a lot of it is licensing and software. And what I found over the years is the return on investment that me and my student got from doing a formal license wasn't nearly as beneficial as having shared IP that brought in more research funding and established these long-term relationships. So I tried it once, said, you know what, the return on my investment is way more valuable if I give away my software, my IP, recognize that there is some co-creation, and use that to strengthen my funding and continue these long-term relationships where industry, even despite the economic downturns, even despite the pandemic, continued to fund our research because they saw such a huge investment, return on their investment. As a VP research, what I'm learning is our IP policies have to be user-friendly to not tie the hands of our innovators once they want to commercialize. And they also have to be user-friendly to attract investment from venture capitalists into our inventions and allow sharing of revenue, sharing of IP in a way that's also simple and easy to understand.
Well, thank you very much. That was indeed a very well-received seminar, and thank you for that very interesting sharing of your thoughts. So please give her a big round of applause. And thanks to all of you for joining once again this international seminar series. I look forward to seeing you next Friday. Thank you.
Thank you all very, very much. Really appreciate the conversation, the opportunity. Thank you.